morning, friends. In this chapter, up to this, we discuss about the types of the material. That means the three types of the material: conductor, insulator, and semiconductor. And also we discuss about the energy band diagram for conductor, insulator, and semiconductor. So there is only the information about the semiconducting material and also types of material. Now, up to this, our chapter is beginning. The intrinsic semiconductor. That means the pure semiconductor. Already we know about that. In semiconductor, at 0 Kelvin temperature, that means at absolute zero temperature, all the valence electron in silicon and germanium are bound in covalent bond. Therefore, at this 0 Kelvin temperature, valence electrons are absent. Therefore, semiconductor act as a perfect insulator. As the temperature increases, so several covalent bonds are broken and electron becomes the free. And this electron take the part for the conduction of electricity. It means the conductivity of semiconductor increase with increase in temperature and resistivity is decreased. Now here today in this portion, intrinsic semiconductor, we are going to discuss about, explain the intrinsic or pure semiconductor. Or question is also asked like this way: write the electron configuration for pure silicon and germanium semiconductor and explain it. For that purpose, the primary semiconductors are silicon and germanium. Silicon and germanium. The atomic number of silicon is 14. Electron configuration of silicon. Electron configuration of silicon is silicon 14, 1s2, 2s2, 2p6, 3s2, 3p2. So here the K and L cell are completely filled while the M cell is partially filled or not complete. Here K and L cells are completely filled while M cell is partially filled. Thus, silicon has 4 valence electrons corresponding to the 3s and 3p state. Now, for germanium, atomic number of germanium is 32. Its electron configuration of germanium is germanium 32, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p2. So here the K cell, L cell and M cell are completely filled. Why? The N cell is partially filled. Here K, L and M cells are completely filled. While N cell is partially filled. Thus, germanium has 4 valence electron corresponding to the 4s2, 4p2. Thus, the silicon and germanium are tetravalent. Thus, silicon and germanium are tetravalent. Tetravalent atoms. In crystal of silicon and germanium, each silicon or germanium atom has the 4 electrons, 4 valence electrons. Thus, each silicon and germanium atom form a 4 covalent bond with its neighboring other silicon or 4 germanium atom by saying 1 electron. In silicon or germanium crystal, each silicon or germanium atom have 4 valence electron. So they form 4 covalent bond with other 4 neighboring silicon or germanium atom by saying 1 electron. By saying 1 electron. Therefore, at 0 Kelvin temperature, the two-dimensional structure of crystal structure of silicon or germanium is shown in figure. At 0 Kelvin temperature, all valence electrons are bound in covalent bond. Thus, silicon or germanium act as a perfect insulator. Because there is the absence of valence electron, there is the no valence electron. All valence electrons are bound in covalent bond. Therefore, the conductivity of the pure silicon or the germanium crystal is 0 and resistivity is high. Therefore, it acts as a perfect insulator. Clear this? Okay. Now here in figure, the +4 represents the silicon or germanium atom. Here the dark circle represents the valence electron. This valence electron are sharing by one electron of this silicon or the germanium atom and form this covalent bond. There is the covalent bond. This silicon or the germanium atom forms the 4 covalent bond with its other neighboring 4 silicon or germanium atom by sharing the 1 electron. Therefore, all the valence electrons are bound in covalent bond. So as a result, at 0 Kelvin temperature, the silicon or the germanium crystal act as a perfect insulator. While in 3 dimensions, the silicon and germanium have the diamond-like structure. Diamond-like structure. In 3 dimensions, silicon or germanium have diamond-like crystal structure. So there is the note about the pure silicon or the pure semiconductor. That as the temperature increases, what's happened? The covalent bonds are broken. As a result, the free electron and what are the hole? But the conductivity of the pure semiconductor is increasing. As the temperature increases, some covalent bonds are broken and electron becomes the free. And conduction of electricity takes place. Conduction of electric charge take place. So there is the discussion about the pure semiconductor or the intrinsic semiconductor. Clear this? Okay. Again, the silicon and germanium are the primary semiconductor. Silicon has the atomic number is 14. Its electronic configuration is silicon 14, 1s2, 2s2, 2p6, 3s2, 3p2. Here K and L cell are completely filled while the M cell is partially filled. So thus in silicon has the 4 valence electron corresponding to the M cell. Now the atomic number of germanium is 32. Electron configuration of germanium is germanium 32, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p2. So here K, L and M cell are completely filled while the N cell is partially filled. Thus the germanium has the 4 valence electron corresponding to the 4s2, 4p2. Thus the silicon and germanium are tetravalent. Now in silicon and germanium crystal, each silicon or the germanium atom have the 4 valence electron. So each and every silicon or germanium atom form 4 covalent bonds with other 4 neighboring silicon or germanium atom by sharing 1 electron. At 0 Kelvin temperature, the 2-dimensional crystal structure of silicon and germanium is shown in figure. At 0 Kelvin temperature, all valence electrons are bound in covalent bonds. Thus, the silicon and germanium act as a perfect insulator. In 3 dimensions, silicon or the germanium have the diamond-like crystal structure. As the temperature increases, some covalent bonds are broken and electron becomes the free and conduction of electric charge takes place. Clear this thing? Okay. After that, we discuss about what is the hole or the concept of hole. Now, next question is explain the concept of hole in intrinsic semiconductor, or what is the hole, right? For that purpose, just we discussed about that in pure semiconductor. At 0 Kelvin temperature, all the valence electrons are bound in covalent bond. Therefore, there is absence of free electron or the valence electron in pure semiconductor. Therefore, at 0 Kelvin temperature, silicon and germanium, pure semiconductor act as a perfect insulator. So we can add like this way: at 0 Kelvin temperature, in silicon or germanium crystal, all valence electrons are bound in covalent bond. Thus, also, there is no valence electron in crystal. Therefore, it behaves as a pure insulator. At 0 Kelvin temperature, all the valence electrons are bound in covalent bond, just we discussed. Right? Therefore, so there are no valence electron in crystal, therefore it behaves as a pure insulator. At room temperature, silicon or germanium crystal get the heat energy, again thermal energy. So some electron, so the energy of some electron becomes more than binding energy in a bond. Thus, such covalent bond is broken and electron becomes the free. Such covalent bond are broken and electron becomes the free. And these free electrons are responsible for the conduction of electric charge. Such free electron is responsible for conduction of electric charge. Right? So, at room temperature, silicon and germanium crystal get the thermal energy. As the temperature increases, thermal energy of the silicon and germanium crystal increases. So the energy of the some electron becomes the more than its binding energy. Thus, the such covalent bonds are broken and electron becomes the free. Such free electrons is responsible for the conduction of electric charge. As the covalent bonds are broken, the electron becomes the free. Right? So, vacancy of electron is formed in covalent bond. That means the deficiency of an electron is take place. This deficiency or the vacancy of electron is known as hole. Is the covalent bond broken? And electron becomes the free. The vacancy or deficiency of an electron produced in a covalent bond. This deficiency or the vacancy of an electron is known as what? Such vacancy of an electron is known as what? Hole behave as the positive charge particle. Actually, the hole has the no any charge, but it has the strong attraction about the electron. So we believe that it possesses the positive charge. Hole act as a positive charge particle. But hole has no any charge. But it has strong attraction for an electron. So, we believe that it hole has positive charge. Now, what is the hole? Yes, the covalent bonds are broken. So electron becomes the free, and as a result, the vacancy of an electron in covalent bond is take place or the formation. This vacancy of an electron is known as the hole. The vacancy of an electron is known as hole. Hole act as a positive charged particle, but in real, the hole has the no any charge, but it has the strong attraction about the foreign electron. So we believe that the hole has the positive charge. Right? In pure semiconductor, the free electron or the valence electron and hole are the majority charge carriers or the charge carriers. In pure semiconductor, valence electron and hole are charge carriers. So that is the concept of the wall. Right? Again, at 0 Kelvin temperature in silicon and germanium crystal, all valence electrons are bound in covalent bond. Right? So there is the no valence electron in crystal of silicon and germanium. Therefore, it behaves as a pure insulator at absolute 0 temperature or 0 Kelvin temperature. At the room temperature, silicon and germanium crystal get the thermal energy. So the energy of the sum of these electrons becomes more than its binding energy. Thus, the such covalent bonds are broken and electron becomes the free. Such free electron or the valence electron is responsible for conduction of electric charge. Now, as the covalent bonds broken and electron becomes the free, the vacancy or deficiency of an electron produces the format in covalent bond. Such vacancy of electron is known as a hole acts as a positive charge particle, but the hole has the no in charge, but it has the strong attraction for an electron. So we believe that the hole has the positive charge. In pure semiconductor, valence electron and hole are charged carriers. Clear this thing? Okay. Now, how the conduction of electric charge take place in pure semiconductor? So next question is that explain conduction of electric charge or the electric current in pure semiconductor. How the electric current is formed in pure semiconductor. So we start our discussion about that. At room temperature, some covalent bonds are broken. Therefore, the electron becomes the free and bonds are also formed. That means the free electron and hole are formed. Right? So as shown in the figure at position 1, this covalent bond is broken and hole is formed. So this electron becomes the free. So whatever the electron becomes the free from the covalent bond, act as a free electron and traveling from less electric potential to the high electric potential and forms the electric current IE. While the hole has the strong attraction about the electron, so that pull down the electron from the neighboring covalent bond. So here this covalent bond is broken, here the hole is formed at position 2. And this electron is filled in this. Therefore, the hole are moving in opposite direction of the electron. Hole are moving in this direction. That means from higher potential to the lower potential. Thus, in pure semiconductor, the conduction of electric charge takes place due to the motion of the electron and bounded electron. That means the motion of a one. Right? So we can act like this way at room temperature. Some covalent bonds are broken. So electron becomes the free and holes are formed. In figure at position 1. this free electron act as a free electron and form an electric current IE. So, due to the broken of the covalent bonds, electron becomes the free and bond is formed. As shown in the figure at position 1. This free electron acts as a free electron and forms the electric current IE. Now, the hole has attacked the electron from neighboring covalent bond. Thus, what is formed at point 2. So, holes are moving from less to the higher potential, higher to the less potential. And form an electric current IH. Therefore, total electric current is I is equal to IE plus IH. Thus, in pure semiconductor, the electric current is formed due to the motion of free electron and also the motion of a hole. That means the motion of a bounded electron. Bounded electron, that means these covalent bonds are broken, this electron is bound. Again, this covalent bond broken, this electron is bound in next one. Therefore, the hole are moving from higher potential to the lower potential, while the free electron becomes, or the free electrons are moving from less potential to higher potential. Therefore, the total electric current in pure semiconductor is I is equal to IE plus IH. IE plus IH. Now, in pure semiconductor, the number density of the electron and number density of the hole are same. Ne is equal to NH is equal to NO. So that is about the concept of the hole, and that is about how the conduction of electric charge takes place in pure semiconductor. In pure semiconductor, electric current is formed due to the motion of the free electron and also the hole. While the hole are formed due to the broken of the covalent bond. As the covalent bonds are broken, the numbers of the free electron format and hole format are same. Therefore, the number density of the hole and number density of the electron are same, and that is known as the number density of the intrinsic charge carrier.